Welcome to section 9.2, graphs of polar equations. Today we are going to show you graphs of polar equations. There are ways to do this. I'm just going to show you what the graphs look like today. So here we have graphing polar equations. We graph polar equations by making tables. So if I have the polar equation r equals 3 cosine theta, we make a table. And we use a bunch of the different angles of the unit circle. We find what the results are. This one's round to the nearest tenth for what we get back. And if you graph this on the polar plane, you would see a circle there, and the circle has a radius of 1.5. But this is what it would look like. Okay, here we have graph r equals 3 sine theta. We're doing the same thing. We make a table, and we see what we get back when we plug our different angle values in. And we get a graph again of radius 1.5. And this time our circle is above the polar axes. Same idea, we get these negative radiuses. That's why we are in the top part of our circle, of our polar plane. I am not going to have you guys graph like this today. I'm just showing you today what these graphs look like. So these are the types of graphs we get from polar equations. And there's different varieties. We get circles, what we just saw on the last ones. If we just have some number times cosine or some number times sine, we get circles. All right, and this is a question of where the circles are positioned. All right, we have positive for the cosines. Positive is on the right side, negative is on the left side. For sine, positive is above, and for negative, sine is below. The next thing we get is what we call limicons. And these ones have a little loop in the middle there, you'll see. Depending on the equation, you get different types of limicons. On the left there, you have a limicon with an inner loop when a is less than b. So you'll see the equation is a, and then you have plus or minus b cosine, or you have a plus or minus b sine. So if a is less than b, we get this limicon on the bottom. If we have a and b are the same, we would call a cardioid. So a plus b cosine theta gives us our cardioid. And then if you have b is less than a, which is less than 2b, and like I said, this gets a little crazy. I'm just trying to show you what they look like. We get this thing called a dimpled limicon. And when a is greater than 2b, you get a large number, and greater than 2 times b, we get this thing called a convex limicon. These are all types of limicons. Don't have to memorize this, just these are the types of graphs you would see if you would graph these. I'll show you some at the end. What I think are sort of interesting are the roses and the lemniscates. So roses, like it shows, it has petals basically. So you put some number times the angle measure inside the function. So a cosine n theta, or r is sine n theta. We get these different things. N has to be greater than 2. It's an integer, so we can't have like 1.3s. So if n is odd, we have n petals. So if you have like a 3 in there, you have 3 petals. If you have 5, you have 5 petals. If the n is an even number, you get twice as many petals as the n. So if you have n equals 2, you get 4 petals. N equals 4, you get 8. Okay? And they call these roses. And you get a whole bunch of different things in here. Then you have these things called lemniscates. When you have a squared cosine double angle, or a squared sine double angle, we basically get propeller looking things, is the best way to say it, or sideways infinity symbols. And the last one we get is a spiral of Archimedes if we have just an angle measured times a, and then you're adding some number b. And it shows you how they spiral. But these are the different types of graphs you get with polar equations. So we do use these in real life for finding different things, and we'll let stage setups, and there's a lot of applications that it's actually used for. So it says here, the area lit by 2 lights that shine down on a stage can be represented by the equation r equals 1.5 plus 1.5 sine theta. Suppose the front of the stage faces due south. So this is the audience over here. My stage is above here. Describe what the polar pattern is going to tell us about the 2 lights. Well, your lights are shining in this green area. That means if you look at the stage, The stage is pretty well lit, but the lights don't bleed into the audience very much. Very little is in the audience area. This little piece right here down here is in the audience. As you get farther back on stage or farther to the left or right, you get less light also. These do have applications with like sprinkler systems, and there are ways to actually see how to maximize lighting, microphones, spray patterns on things. So these do have applications. All right, we're just gonna graph some polar equations using Desmos to see what they look like. All right, so in Desmos, we are going to do 3 cosine 4 theta. So I just need to get into polar. Notice we have this stuff here. I want to do here. I'm going to change this to this wheel, so now I'm in polar. Okay, so here it says to graph polar equations. We're going to graph these on Desmos. I have these 5 equations. R equals 3 cosine 4 theta. R equals 1 plus 4 cosine 3 theta. R equals 1 minus 4 sine 4 theta. R equals 1 minus 3 sine 3 theta. And R equals 1 plus 3 cosine 4 theta. So I'm going to go to Desmos. I'm going to go right to there. And I'm going to do one of these at a time. So I've typed them all in already. And all I need to do is I'm going to click on the first one. And look what we get. Notice how we have that 4 theta in there. So we should have 8 petals. And that's what we have, 8 petals. You notice our radiuses are 3. So our highest part we go to is at, notice our radius is right there is 3. I'm going to show you the next one. We have 4 cosine of 3 theta. You might be able to figure out what's going to happen next. That's a rather interesting one. Look at that plus 4 out front. We sort of have we have 3 petals, but then we have a double graph going on here because we have 1 plus 4 cosine 3 theta. Like I say, when you graph these things, you get some interesting things. All right, we're going to go to this one. We get 1 minus 4 sine 4 theta, another interesting graph. We have 4 large petals, 4 small petals. Again, we have the petals inside petals. Saying there's a lot of neat stuff you can do with these polar graphs. And there's another one. So we're looking at these different graphs. This is what you see when you do these polar equations. As you go around a circle just one time, of course, if you went around multiple times, you just repeat the patterns. But this is what you get when you graph some of these polar equations. Just want to let you see that. So if you see these in your future, you sort of understand where they're coming from. These are polar equations. All right, so let's get back to the slides. And that is all for graphing polar equations. If you have to graph these by hand ever, you just make a table of values. There are ways to use symmetry, which gets sort of complicated. A lot of the stuff, when you do these, you're going to have graphing technology. But they do have some very interesting graphs when you do this. All right, that's it for 9.2. Thank you for watching, and have a nice day.